Okay, so I still have not received several submissions. I don't know if y'all are seeing them or not. I had one student who brought to my attention that putting them at the bottom of the lesson was not the easiest for them to see, so I will start distributing them later. But if you have not worked yet 2016 problem number 5, then stop the video right now, work it, submit it to me, and then after you submit it to me, go ahead and watch the video. So this is what we're looking at. We've got a cone here, and this cone has a radius of 1/20th of 3 plus h squared, and the height for the entire cone is 10. You know, this cone is not a triangular cone. It's got a curve to it, so that's going to keep us from going to the 1/3 power squared h formula. So it asks us here to calculate the average value of the radius of the funnel. Well, average value, you think average value of a function. Well, what do they give us? They give us the function for the radius. So let's go with going from 0 to 10 and I'm going to pull the 1/20th outside, but I also have that 1/10 because it's 1 over b minus a. So it's going to be 1/20th of 3 plus h squared dh. So pulling that out, that's going to be 1 over 200 times. All right, so this becomes 3h plus h cubed over 3 from 0 to 10. So it's 1 over 200 times 30 plus 1,000 over 3. And you can stop right there. Again, you don't want to mess up with simplifying. You've plugged in the numbers. You could even just write 10 cubed there if you didn't want to take the chance of doing that incorrectly. So this is what we've got as the solution. Again, that's a 3 there. And it asks for units, so this would be in terms of inches. If you did carry it out all of the way and reduced everything down, you come up with 109 over 60. All right, so on to part B. Part B of this question says find the volume of the funnel. Now, to find the volume of the funnel, let's take this into consideration. Let's turn the funnel on its side and let the x-axis cut it in half. So what do we have? We have a bunch of circles being rotated about the x-axis. Well, what we're going to do to calculate the volume is we're going to add up the areas of all of these circles. So how do we get the area of a circle? Well, it's pi r squared and then it's, of course, dh here. So let's square the 1 over 200. It becomes 400. So we got pi over 400 times. All right, now we got to square that entire binomial. So it's 9 plus, 0 to 10. Oh, that's horrible. Y'all thought my handwriting was going to get better because I was going to have so much time to practice it, but it just hasn't happened. 9 plus 6h squared plus h to the 4th dh. Okay, so we integrate this. So pi over 400. Now this becomes 9h plus 6h squared over, 6h cubed over 3, which would just be 2h cubed, plus h to the 5th over 5, and we are again going from 0 to 10. Now again, you can't stop here. You've got to actually show the step where you plug it in. So this becomes pi over 400 times 90 plus, all right, h cubed is 1,000, so that'd be 2,000 plus, and this is 100,000 over 5. Now, the thing about 100,000 over 5, that is 20,000. When I worked the problem practicing up for this, I said it was 2,000, so I got the wrong number here, so I would have missed the point by simplifying further. The numbers are so complicated here, I would not go further. But you could, and in the end, you get 2209 pi over 40. And as far as units are concerned, this is average volume. And it says that the height's in terms of inches, so it would be cubic inches. So that goes for part A and part B. On to part C. I'm going to erase part A over here. Again, you have your video, so you can go back and look at it. Don't get mad at me for erasing, because you can go back and look at it. This is really how I'm trying to get my video to go viral, is by having y'all have to stop and rewind it and so forth. And you're like, oh, I've got 10 million views on this one. So anyway, before I get lame, the next question does say that we want to know at what rate is the change of height occurring when the height is 3 inches and the radius is decreasing at 1/5 inch per second. So R equals to 1/20th of 3 plus h squared. And this is what we're wanting to take the derivative of. Before I do that, I'm going to make this 20r equals 3 plus h squared. So now taking the derivative of this becomes 20 dr dt equals, okay, the 3 has a derivative of 0, so it's just going to be 2h dh dt. All right, so this is leaking at a rate of 1/5, so that would be -4 equals to 2h, and it's interested in when you've got 6. I'm sorry, 3 is your height, so that would be 6 dh dt. So dh dt here is -4/6, and then the because h is linear, it would be -4/6, which I'll write as 2/3 inches per second. So again, that is what we have here for the solution here. Again, hosting a Zoom session for those of you who are taking the test. It'll actually be Saturday the 25th, and I'm going to host it at 11 o'clock. You should have already received an invitation to it if you are taking the test. If you are not taking the test, but you want to have more fun with calculus, then tell me that you want to be invited, and I'll get that taken care of as well. So please, I have not received any questions yet as far as what you would like to, specific questions or general questions at all. So if you have something in mind that you really want me to hit tomorrow during the Zoom session, please do let me know. Again, thank you. Keep up the good work. Make sure you're getting these problems sent in. I will be submitting another problem of the day for you to email and submit to me, and I will do it via an email as opposed to writing it at the bottom of one of these assignments or one of these videos. So keep working hard. Thanks. Bye.